if you take a topic, digital forensics, it's a big topic, and within that topic there are numerous subtopics. And in today's video we are going to talk about one of such important topics, and the topic is memory forensics, and it is actually a subset of digital forensics. And I'm going to explain this memory forensics. We are going to perform a memory forensic investigation here in this video. And before that, if you have no idea what is memory forensics, I'll try to explain in a simple way. First of all, to understand the memory forensics, you need to know what is volatile memory, what is the RAM, random access memory. Actually both are same. First of all, you need to understand that. And RAM, if you take any system, it can be a mobile phone, laptop, desktop, any system, there must be a volatile memory, and the size is comparatively lesser than the actual storage space in your machine. It would be around 8 GB, 16 GB, 32 GB, like that only, because that memory will be used temporarily by the processes, application that are running on your machine. If you turn on the machine, bunch of things will be happening at the back end along with the things that you are doing on the machine. You might be doing some file system activity, you might be watching some videos, you might be running some applications, whatever. The data related to all the activities, all those activities, when the system is turned on, will be stored on volatile memory, RAM, temporarily. That's why we are calling it as volatile memory. The memory forensics is nothing but capturing the state of volatile memory in a file and analyzing that captured memory image on a different machine. And that is about the memory forensics. And in order to carry out the memory forensics, it is not necessary to obtain the access to that machine that you are investigating. Instead, you can capture that memory state of the machine that you need to investigate on a file, and you can investigate that file on a separate machine. That is the biggest advantage of memory forensics. And if you have an interest and some time to learn the memory forensics, it is so easy, because there are bunch of useful tools to learn the memory forensics. Among those tools, Volatility stands out. Volatility is a memory forensics tool managed by Volatility Foundation, and it's an open source tool. Anybody can download and use the tool. And I'm going to use the tool Volatility to analyze the memory dumps that we have. And I'm going to use the TryHackMe room to demonstrate this memory forensics. TryHackMe recently launched this room, and it was very informative, and the details are very amazing. They gave the details in an amazing way. So that's why I chose to walk through this TryHackMe machine. Without further ado, let's begin. Now you are looking at the official Volatility page. It is managed by Volatility Foundation, and the Volatility framework is written on Python. You can see two crucial repositories, Volatility and Volatility 3. Volatility is built upon Python 2, and Volatility 3 is built upon Python 3. And the Volatility 2 is obsolete since we are no longer using Python 2, and Volatility 3 we are going to use for our current assessment. And you can see the description here. Volatility 3 is still under development, so they gave this description as a warning. There might be some features are missing since it is still under the development. And if you want to use the whole plugins of Volatility, then you may use Volatility 2, the Volatility. But for this, for our current assessment, Volatility 3 is sufficient. And let's go to this TryHackMe room. Look at this. Learn how to perform memory forensics with Volatility. And let me admit this. So this room contains few theory topics. Till task 9, it is theory, but I'll try to walk through this theory part very quickly. And the task 10 is the practical investigation. There are two scenarios where they also gave the memory image which is captured from a live machine, and we are going to examine these memory images and answer the following questions. So this would be very interesting, but before that, let's go through this theory topic. And you can see they also gave a machine. It is owned by TryHackMe. You can either do this investigation on the TryHackMe's machine, or you can install the volatility on your machine and you can perform the investigation. If you are performing it on your machine, then it is recommended to download these task files and keep it in your machine and make sure the volatility tree is installed on your machine. Then you are all set to start the investigation. Now let's read through the introduction here. Volatility is a free memory forensic tool developed and maintained by Volatility Foundation, commonly used by malware and SOC analysts with Blue Team or as a part of their detection and monitoring solutions. Volatility is written in Python and is made up of Python plugins and modules designed as a plug and play way of analyzing the memory dumps. Volatility is available for Windows, Linux, and Mac OS, and it is written purely in Python. So they made it clear it is written in Python and it is available for all three major operating systems. And this room uses the memory dumps from TryHackMe rooms and memory samples from Volatility Foundations. Before completing this room, we recommend completing. Alright, they also gave a recommendation, a prerequisite room. It is good to have a knowledge of this Windows processes, but however, we are going to proceed with the further tasks since we have a little bit of idea on this Windows processes. And here is the GitHub page that you can refer. You can refer this page to download the volatility. I'll give this link in the description so you can use it. All right. Now this is just an information, so I'm just marking it as completed. Let's read through the second task, volatility overview. From the Volatility Foundation wiki, volatility is the world's most widely used framework for extracting digital artifacts from volatile memory samples. The extraction techniques are performed completely independent of system being investigated, but offer visibility into runtime state of the system. The framework is intended to introduce people to the techniques and complexities associated with extracting digital artifacts from volatile memory samples and provide a platform for further work into exciting area of research. So this is very crucial information. This is the biggest advantage of the volatility. In fact, the memory forensics. If once we manage to capture the volatile memory state, then we can use the tools like volatility to investigate that and analyze what is exactly happening on that system. And we can perform it independently. That's the biggest fact. And volatility is built of multiple plugins working together to obtain information from memory dump. To begin analyzing a dump, you will first need to identify the image type. There are multiple ways of identifying this information that we will cover further in these tasks. Once you have your image type and other plugins sorted, you can then begin analyzing dump by using various volatility plugins against it, and that will be covered in depth later in this room. All right. This paragraph explains the volatility is all about the plugins. It has numerous plugins, the plugins offered by Volatility Foundation, and also there are custom plugins, numerous custom plugins. You can use those plugins based on your need. And it's all about changing and using the appropriate plugins for that specific scenario. So that is the main thing in the volatility. And since volatility is entirely independent of the system under investigation, this allows complete segmentation but full insight into the runtime state of the system. And this is the biggest advantage, as I mentioned before. At the time of writing, there are two main repositories for volatility, one built off of Python 2 and another built off of Python 3. I explained it few minutes back, but for this room, we recommend using volatility 3, which means that is built on Python 3. Volatility that built on Python 3. Note: when reading blog posts and article about volatility, you may see volatility 2 syntax mentions and used. All syntax changed in volatility 3, and within this room, we will be using the most recent version of plugin syntax for volatility. And there are slight changes in the syntax, the command that we are using. I mean, the command you use between volatility 2 and volatility 3, but it will be very easy, nothing bigger. All right, so this is just an information. We just read this, and going to the task 3, installing volatility. So here they give the steps to install volatility, and you can refer this tool. I mean, you can refer this guide if you want to install, you haven't installed it. Since volatility is written purely in Python, it makes the installation steps requirements very easy and universal for Windows, Linux, and Mac. If you already attempted to use Python on Windows and Mac, it is suggested to begin on Linux. However, all operating systems will work the same. All right. If you haven't installed Volatility, then you can use their TryHackMe's machine to perform the investigation. But in our case, we are going to download the images, and I already installed the Volatility, so I'm going to perform it from the local machine of mine. All right. When downloading, you can make a choice to use the pre-packaged executable file that will work the same, require no dependencies. You can decide to run directly from Python. I think if you go to the Volatility 3 repository, and here you may see the releases page. So the latest release was on December 15th, and you can see the WHL file. That's what they are denoting here. You can use the WHL file for the installation, and they also gave the dependent Python libraries. So the Volatility requires PE file and this version or later, and Capstone the version or later, and Yara Python, it is a recommended package. So Yara Python and Capstone is recommended. PE file, it's mandatory dependency, and you need to make sure the Python version is 3.5.3 or above. And you can simply clone the repository by using this git clone command, and all set. You are all set. You simply navigate to this Volatility directory, and you will see the vol.py file, and you can simply initiate that Volatility tool by using this command. Well, that's it for the installation. Volatility 3 installation is very simple. Moving to the next one, memory extraction. Well, this is the important topic. Before you start examining the memory images, you need to obtain that memory images, right? For that, there are certain tools out there. So you may use those tools to extract the state of volatile memory, and you can see the list of such tools. The FTK Imager, it's a popular tool to extract the memory image. Redline, dumpit.exe, it is another popular executable to extract the memory images from the Windows machine. And you can see these two utilities to extract memory images of Windows machine. Memorize, fast dump, these two are other tools. So when using extraction tool on a bare metal host, it can usually take a considerable amount of time, because it is going to extract the entire volatile memory state, the whole thing that are happening on the volatile memory. So obviously it will take its time, and take this into consideration during the investigation, and that is their recommendation. Most of the tools mentioned above for memory extraction will output .raw file, with some exceptions like Redline that can use its own agent and session structure. Well, they are also mentioning that the file extension mostly would be .raw, or it can be .vmem, .mem, like that. And you can see an image, so they gave the memory image, and there is, not only extracting the memory image of the bare metal host, you can also extract certain files from the virtual machines to carry out this memory investigation. And gathering the memory file can easily be done by collecting the virtual memory files from the host machine's drive. This file change depending on the hypervisors you are using. You might be using VMware, VirtualBox, or something else. So the file that the memory file, the extensions will be varying based on the hypervisors you are using. That's what they are mentioning. And you can see the memory, the file extension, the file with the extension in each hypervisor. Well, yeah. And if you're using VirtualBox, then .sav file, this is only a partial memory file. They also gave a hint here. And exercise caution whenever attempting to extract or move memory from the both bare metal and virtual machines. So you have to be careful. If you are making any mistake, then you might be tampering the machine's data or the machine's entire operating system. So you have to be careful while extracting. And this one is done. We read through the theory part, and moving to the next, plugins overview. Since converting to Python 3, the plugin structure for Volatility has changed quite drastically. In previous Volatility versions, you would need to identify a specific OS profile exact to the operating system and built version of the host. which could be hard to find or used with a plugin that could provide false positives. With Volatility 3, profiles have been scrapped. With Volatility, will automatically identify the host and build a memory file. So this is a biggest difference between Volatility 2 and Volatility 3. Once I started using, I'll try to explain. There is a parameter that you'll be mentioning, the parameter called profile. So in Volatility 3, you have to mention what profile it is. So every machine, it will be having a profile. So you have to mention the profile explicitly in Volatility 3. But Volatility 2. But in Volatility 3, the profiles are scrapped. So you need not to mention these profiles, since this tool automatically detects what operating system it is. Well, that's the biggest advantage. The naming structure of plugins has also changed. In previous versions of Volatility, the naming conventions has been simply the name of the plugins and was the universal for all the operating systems and profiles. Now with Volatility 3, you need to specify the operating system prior to specifying the plugins to be used. For example, Windows.info and Linux.info. Well, the first part, the part before period denotes the operating system, and the part after the period denotes the module, the plugin name. So here it is Windows operating system and the info plugin. So this is the word you have to use along with that memory dump name in order to get the information about that Windows system. Well, that's an advantage. In Volatility 3, you simply need to use the system. I think it is system info or a plugin name. There is a plugin name to find the info in Volatility 3. You simply be using that plugin name without mentioning the operating system name here. You will be mentioning the operating system in a profile. But in Volatility 3, it is changed. And you can see the list of operating systems you can use here: Windows, Linux, and Mac. It is supporting 3 major operating systems. There are several plugins available with Volatility as well as third-party plugins. We will only be covering small portion of the plugin that Volatility has to offer. That one they made clear. We are going to look a tip of the iceberg. So there are so many things. There are plenty of things to learn. It's like an ocean. We are going to learn only few droplets of that. Well, to get familiar with the plugins available, utilize the help menu. As Volatility 3 is currently actively under deployment, there is still a short list of plugins compared to its Python 2 counterpart. However, the current list still allows you to do all your analysis as needed for this room. Okay, so this is a hint or a warning they give. If you are trying to do certain things with Volatility 3, it might not be supporting. All right, now read the above and review the Volatility help menu. I have already installed the Volatility 3 on my machine, so I'm simply going to call that Volatility from here. So I have installed it in the tools directory, Volatility 3 and vol3.py, and that's the file. And I'm mentioning -h to read the help menu. And here you can see the help menu of Volatility 3. So there are huge things listed here: an open source memory forensics framework. So look at this help menu. So if you have any doubt, you can refer this. And the plugins. For plugin to specific options, they gave the list of plugins available by default. And also the operating system names they are mentioning before the period. So this is how you have to mention this. So this is the format: operating system, period, plugin name. Well, yeah, we explored the menu, help menu. Moving to the next, identifying image info and profiles. Well, it's a huge, it's a basic task. Whenever you begin the memory forensics, you have to understand, you must know which operating system you are dealing with. You are performing the investigation on which operating system. And to find that, there are certain plugins. In Volatility 2, the plugin name is image info. And this is what I was mentioning. And in Volatility 3, you can mention the operating system and also the plugin name. Well, by default, Volatility comes with all the existing Windows profiles from Windows XP to Windows 10. So look at this. They mention only till Windows 10, and I'm not sure whether it is supported Windows 11, but Windows 10, the volatility was supporting till Windows 10 at the time of this ROM release. Image profiles can be hard to determine if you don't know exactly what version and build the machine you extracted a memory dump from was. In some cases, you may be given memory file with other context, and it is up to you to figure out where to go from there. In this case, Volatility has your back and comes with image info plugin. So in Volatility 2, this is the plugin you have to use. This plugin will take a provided memory dump and assign it to a list of best possible OS profiles, and it will be listing the best possible OS profile. It will be giving you some choices. Then you can choose the profile names one by one, and you can find the appropriate profile. And this OS profile is deprecated in Volatility 3. It is not used anymore. So we are going to use a different technique here. We are going to use simply windows.info or linux.info or mac.info to find which operating system you are dealing with, which is giving the valid outcome, then that is the operating system you are dealing with. So that is the simple thing. So here is the command python volpy -f windows.info, and let me play this video here. Look at this. They are mentioning the executable name and -f to bring the memory dump, and Windows operating system name, and dot, and then the plugin name. It will be giving you the lot of details about the operating system, and you can see the system root. It is C:/Windows, so which is indicating that it's a Windows machine. So this is how you have to find the operating systems that you are dealing. And yeah, read the above and move on to the next section. And to practice any commands in this room, you can utilize either of memory files present on the, okay, this is just an information that you need to know. Moving to the next one, listing processes and connections. So let's read through this interesting task. 5 different plugins within Volatility allow you to dump processes and network connections, each with varying techniques used. In this task, we will be discussing each and its pros and cons when it comes to evasion techniques used by adversaries. Well, yeah, we have in this section, we have around 5 plugins, and we are going to use those plugins to find the details about processes and network connections of the machine that you are dealing. And the most basic way of listening processes is using the PS list, and you simply need to replace the plugin name once you found the operating system. So it's all about using the appropriate plugins, as I mentioned before. So when you use this PS list, let's see what happens. Now they are executing this command python 3, and look what's going to happen. Look at this. Actually, it lists the processes, entire processes, along with its parent process details, and also the created time. So it is like an image of your task manager in the Windows operating system. So it gives the equivalent task manager equivalent result. And some malware, typically rootkits, will, in attempt to hide their processes, unlink itself from the list. By unlinking themselves from the list, you will no longer see their processes using PS list. To combat this evasion technique, we can use PS scan. This technique of listing processes will locate processes by finding the data structures that match __ process. Actually, it is a low level thing. I have no idea what it is, but they are recommending to use PS scan to find the processes that are excluded in the PS list result. The processes that are using some advanced evasion tactics. Well, here is the command. They simply changed the PS scan. Instead of PS list, they are using PS scan, and that is what changed here. Let's see what happens here. So they are using the same command, only the plugin name changes. And look at this. It is actually giving some additional process names compared to the previous results. I'm not sure whether it is giving here, but this is the command you need to use to find the hidden processes. Well, the third one, the third process plugin, PS3, it would be very useful, I believe, because it is offering the details of the parent processes in detail. The PS3 doesn't offer any kind of special techniques to help identify evasions like last two plugins. However, this plugin will list all the processes based on their parent process ID using the same methods as PS list. This can be useful for an analyst to get full story of a process and what may have been occurring at the time of extraction. Well, this is what the command, only the plugin name changes. So let's see what would be the outcome here. It would be showing the process tree, the details of the parent process, the complete stuff. And look at this. And here the first column shows the process ID and the second column shows the parent process ID, and you can see the image, file info, names, and the stuffs. And look at these details. You can link with the parent process ID. You can link every process with its parent process by seeing this outcome easily. Now that we know how to identify processes, we also need to have a way to identify the network connections present at the time of extraction. So when you are extracting the data from that machine, what are the network connections present in that? So you can find that by using the plugin netstat, and here is the command. So you can use the netstat command to find that stuff. And this command in current state of Volatility 3 can be very unstable. So they are confessing it. Since it is under the development, this might be troubling you. But to overcome this, they are actually recommending to use a tool called bulk extractor. Actually, this tool is present in the Kali Linux distribution. So this is used to extract the pcap file from the memory dump, so that you can examine that pcap file by using the tools like Wireshark, and you can read the network connections. Okay, the last plugin we will cover is DLL list. This plugin will list all the DLLs associated with processes at the time of extraction. This can be especially useful once you have done further analysis and can filter output to specific DLL that might be indicator of specific type of malware you believe to be present on the system. So whenever you begin the investigation, you have to perform all the basic stuffs that I have shown before. You have to look for the operating system, the basic processes running, the processes with the parent process details. So those things you have to find, and you need to see, you need to differentiate the typical process and the suspicious one. So once you identify the suspicious process, you can use this DLL list in order to filter out the DLLs that belongs to that specific suspicious process. Well, look at this command DLL list. When the plugin DLL list is used, what would be the outcome? Let's see that. And here is the outcome. It shows a bunch of details, and you can see the DLLs associated with every process. And you can see the process ID 1588. It is nothing but WAUCLT. That is the name of the program, and its associated DLLs given here. So these are the dependent DLLs to this program. And once you identify the suspicious program, you can look for the DLLs associated with that. That would be making your investigation easier. Well, this part is done. Moving to the next, volatility hunting and detection capabilities. That is the next task. And Volatility offers a plethora of plugins that can be used to aid in your hunting and detection capabilities. When hunting for malware or other anomalies within a system's memory, it is recommended that you have a basic understanding of how evasion techniques and various malware techniques are employed by adversaries, as well as how to hunt and detect them before going through this section. Well, this first plugin we will be talking about is one of the most useful when hunting for the code injection is malfind. So this is the volatility plugin usually used to identify the code injection. Well, this plugin will attempt to identify the injected processes and their process ID along with offset address and hex ASCII disassembly view of the infected area. So it gives a lot of details about that process. So what code has injected into the process. So it gives whole details. This plugin works by scanning heap and identifying processes that have executable bit set RWE or RX. So it's a low level thing. I need to learn so many things on this, but for now you just need to understand what malfind does. It finds the process with the injected code. Well, yeah, based on what malfire identifies, the injected area will change. The MZ header indicates the Windows executable. The injected area could also be directed towards the shell code, which requires further analysis. Well, let's see the usage of this malfind plugin. What we are getting: Windows.malfind. Look at this. It gives the hexadecimal view. Yeah, as they mentioned here, it gives the hexadecimal ASCII and disassembly view of the infected area, which is really interesting. And the next one, Volatility also offers the capability to compare the memory file against Yara rules. Yara scan. Well, it is another excellent advantage. If you are investigating any machine that you suspect to be infected by the malware, then you can use this Yara scan plugin to run that memory dump so that it will be detecting if any Yara signatures getting matched. So that is the simple command here. So here you'll be mentioning the memory dump, the file that you obtained from the machine. Yeah, with this, yeah, there are other plugins that can be considered as the part of the volatilities hunting and detection capabilities. However, we'll be covering them in the next task. All right, that is just a note. The next one, advanced memory forensics. So this is the last theory part, but it has some advanced topics, advanced concepts. I'm not pretty much sure about these advanced concepts, so I'm simply going to read through this. Advanced memory forensics can become confusing when you begin talking about system objects and how malware interacts directly with the system, especially if you don't have prior experience hunting some of the techniques used as hooking and driver manipulation. When dealing with advanced adversary, you may encounter malware, most of the time rootkits, that will employ very nasty evasion measures that will require you as an analyst to dive into the drivers, mutexes, hooked functions. A number of modules can help us in this journey to further uncover malware hiding within the memory. Well, there are the evasion techniques. I mean, the first evasion technique we'll be hunting is hooking. So look at this type of hooking here. So there are 5 methods: SSDT hooking, IRP hooking, IAT hooking, EAT, and inline hooking. So hopefully we can make another video to explain this hooking, but for now let's move on. We will only be focusing on hunting SSDT hooking for this room, and it is one of the common evasion techniques used by the adversaries. And the SSDT plugin will search for hooking and output its results. Hooking can be used by legit applications as well. So while analyzing, you have to be very careful. You should be having that knowledge of differentiating the malicious one from the legit one. And here SSDT stands for System Service Descriptor Table. The Windows kernel uses this table to look up system functions. An adversary can hook into the table and modify the pointers to point to a location that rootkit controls. So it's an advanced stuff. There can be hundreds of table entries that SSDT will dump. You will then have to analyze the output further to compare against baseline. A suggestion is to use this plugin after investigating initial compromise and working off it as part of your lead investigation. Well, here is the command. As usual, we are simply modifying the plugin name for this complicated plugin as well. So let's see what happens here. So they are executing the same command. Only by changing the plugin name, you will see some different results. Look at this, and it contains the list of SSDT hooked stuffs, I guess. Adversaries will also use malicious driver files as a part of their evasion. Volatility offers 2 plugins to list drivers. The modules plugin will dump a list of loaded kernel modules. This can be useful identifying active malware. However, if a malicious file is idly waiting hidden, this plugin may miss it. So they gave it as a warning. This plugin is best used once you have further investigated and found potential indicators to use as input for searching and filtering. Here is the syntax. Let's see what it does. They are simply mentioning module plugin is advanced compared to the previous one we have seen, the SSDT. Yeah, look at the outcome here. Pardon me, actually the modules plugin they are recommending to use first, then you have to use the driver scan. So here is the definition. The driver scan plugin will scan for drivers present on system at the time of extraction. This plugin can help identify driver files in the kernel that modules plugin might have missed and were hidden. So what are the stuffs modules plugins missing? You can use to find such stuffs. You can use driver scan to find those stuffs. As with the last plugin, it is again recommended to have prior investigation before moving on to this plugin. It is also recommended to look through modules plugin before driver scan. Yeah, well, look at the command to use the driver scan. Only the plugin name changes. In most cases, driver scan will come up with no output. However, if you don't find anything with modules plugin, it can be useful to attempt using this plugin. So they are giving the scenario here. If you get nothing with this plugin, then use driver scan. It might be giving you some interesting stuffs. Well, they have listed the other plugins that can be used for advanced malware. To investigate the advanced malware in memory. And look at these plugins here: modscan, driver IRP, callbacks, IDT, API hooks to find the API hooking, I suppose, and mod dump handles to find the list of handles. Well, some of these are only present in Volatility 2 and are part of the third-party plugins. To get most out of Volatility, you may need to move to some third-party or custom plugins. So they are giving it as a note. So they are mentioning it again and again. Volatility 3 has some constraints since it is under the development. And look at this question. Read the above and practice looking through the SSDT and drivers. So they are recommending to look through the outcomes of this SSDT and driver scan plugin command. We have gone through that outcome and research the other plugins provided. All right. Some of them will be used within the practical investigation. So if you want to find the list of list of the other plugins, then Volatility GitHub page has the list of common plugins that you may use. I guess you have to look for that in the docs folder, not in the docs. So let's search in the Google Volatility plugins. So here is the link, and look at this. There are multiple repositories by multiple researchers. All these repositories contains some custom plugins, custom volatility plugins. It can be used for specific things. So there are a lot. So you can load more and you can see multiple custom plugins. Well, okay. Now we have done the theoretical part. With all these theory concepts of memory forensics with volatility, the part 1 ends. We are going to carry out the practical investigation in the next part, the part 2 of this video. And thanks for watching.